a sort of an opportunity where the Cloud Expo folks gave me some space, and I thought, well, I don't have any sponsors other than myself and the company that I've been working with, but I'll go ahead and organize this and see if people come. And so I was trying to think of a good theme, something that I was interested in, thought maybe other people would be interested in. And right now there's seems to be this growing, seems like a growing space, which I didn't think was going to grow any further, but the platform as a service space seems to be growing, especially around open technologies to build your own platform. And I don't know, we'll see how many more there are, but right now it seems like we've got a pretty good start with these different clouds or cloud technologies. And what I thought I'd do is, you can see from here up on the screen here, I've got some of the speakers that will be talking. They're not all here yet. I think some of them are still networking over there, but I think I'm expecting everyone to show up. But to kick this off, what I thought I'd do is just find out a little bit about you and then tell you a little story, and then we'll go ahead and give the lighting thoughts, if that makes sense. So how many of you work for a company that provides some sort of platform or cloud platform? Raise your hand. So maybe about a third or a half of you. Okay, cool. How many of you are trying to just learn about these technologies and came here to find out what's going on? Okay. The other half, right? Anybody else here for any other reason? Okay. Well, I can tell you that even as someone who's been involved with large numbers of cloud technologies, it's still, even if you're involved with one, this is still an opportunity to learn about the others. So that's one of the things I hope to accomplish here tonight. But if any of you have been to any of the cloud camps I've organized in the past, I often tell this little story about what I believe we can learn from the past in the PC era. And it seems to be proving more and more true every day, so I thought I'd just go ahead and share it with you. And that is, when I first learned to program, it was, I wasn't a programmer by trade. I had learned programming in college. I learned Visual Basic, and I learned SQL Server and Microsoft Access, and I would build solutions for customers, mostly around the Windows, the Microsoft stack. And I learned a couple things sort of about being practical and building solutions that meet the needs, not necessarily like look good or seem cool. But I also learned about the PC era, and one of the things I learned was that a long time ago, even before I was programming, the Apple II had been basically the first time that we saw a PC kind of hit the market and succeed, in a way that like consumers are actually buying this thing, right? And that was really the first kind of proving ground for the PC era, where it proved that there was a market there and that a company could make a lot of money selling that kind of product. If you fast forward to the cloud, what would you say was the first kind of successful cloud proof of concept that actually turned into a successful product? Amazon EC2, perhaps, right? Because that was, in my opinion, sort of like the Apple II of the cloud. It proved that this concept was going to be successful, and but it was proprietary, right? It's proprietary software on a proprietary cloud hardware. Now, go back again to the PC era. The competitor that ended up competing successfully against the Apple II was, of course, DOS, right? And you could make an argument that it would be the equivalent of proprietary software that ran on multiple hardware vendors, right? You've got IBM, HP, Compaq, Dell, these guys, right? Yeah.
I still think CPM 86 is going to be successful.
But what was interesting is there were multiple versions of DOS, right? So that was kind of interesting, right? So, thank you for that, Roger. I'm sure you're
just for the other old folks in the crowd.
I'm sure you just hold your breath. I'm sure it'll pan out.
I am okay.
So, but, okay, bear with me on this story, because it actually kind of starts making sense here in a minute. So in the equivalent, in the cloud, you might say, that of software, of cloud software that ran on multiple hardware products would be, what would you think that could be? Something similar to Amazon EC2, but software. Come on. I know you guys can think of it. OpenStack is one. And you could even make the argument, so I'm not suggesting this is a good argument, you could make the argument maybe vSphere or something like that. You could build something kind of like cloud on VMware or something, right? Not that that was very successful, but anyway, you know, it's been holding its own, I guess. But anyway, the point is, you can make the argument that those were the equivalent of DOS. Now, once Apple II and DOS were successful, and the market started to get big, now you saw Apple and Microsoft double down on the market by coming out with, in Apple's case, the Macintosh. So what they came out with was a much better UI, with a GUI and a mouse and all that kind of stuff, right? Again, though, the Macintosh was proprietary software running on proprietary hardware. And then you go over and look in the on the Microsoft side, and what do? They came out with Windows, right? Again, it's proprietary software, but the model works because it could run on different hardware vendors, right? Now, if you look in the cloud today, you might ask yourself, okay, what's the equivalent of Macintosh in the cloud? There's a couple different opportunities to claim that. I used to say it was Salesforce with Force.com because honestly, that was actually a very nice product, incredibly proprietary. But Force.com is a very nice platform as a service. Okay, but I would say just it wasn't quite as successful to claim that spot. I think maybe Heroku would actually claim that spot. Heroku was proprietary cloud software, platform as a service, running on top of proprietary infrastructure as a service. They didn't own it, but it was proprietary. So it's a proprietary stack. I don't know if you know this, but Heroku was actually acquired by Salesforce. So Salesforce did such a very nice job of their own past that they realized it was too proprietary. And while Heroku is proprietary cloud, it actually makes it very easy to run open source Ruby on Rails code and other stuff. But anyway, so now you got Heroku running on top of, in this case, Amazon EC2. So then the argument would be, what would be the equivalent of Windows in the cloud? What's that?
Azure.
So it's going to be something that's at the platform as a service layer. Yeah, okay, Azure would be the Microsoft of the cloud from Microsoft. Right?
Yeah.
Okay, but that hasn't really been that successful. I don't think we've seen people deploying Azure on different clouds.
If you look at what iOS has done, in the sense that you have literally tens of thousands of applications that people are accessing on their phones.
Well, I'm going to come back to that. That's not the answer I'm looking for. I'm going to come back to that because there's a good point to be made there. However, what I'm looking for is a platform as a service software that you can run on multiple clouds. Okay, now I come from the CloudCamp space, and we've been around for a long time, doing these events for a long time. And there have been many attempts to create this kind of software. And two that have made it kind of over the years and kind of evolved are Cloud Foundry and OpenShift. Both of those have been around for a long time and have been growing in different ways, but have withstood the test of time, at least until now. What's interesting about that, by the way, is that they were both just ideas at the very first CloudCamp we ever held. Just a little bit of history for you. We held our first CloudCamp June 24th of 2008, and a guy named Chris Richardson had we had this event where it was an own conference and we had all these discussions, and one of the discussions was, what is cloud computing? This is super early in the cloud space, and one of the breakout sessions was, what is platform as a service? And there were 2 people at that CloudCamp, or 3 people
Java guy?
Yep.
Yeah, Spring.
He wrote Pojo in Action,
Ah, I
and
see.
he's been around for a long time. Two other people were Isaac Roth and Tobias. Yeah, yeah. And those guys wanted to sponsor the CloudCamp. They didn't have a company name yet. I told them to make up a name. They made up the name OSS 1701, which is extremely geeky, open source software, USS Enterprise 1701. Not a good name for a company, but nonetheless, that's what they sponsored their first CloudCamp with. Eventually, they changed the name to Makara, created this platform as a service software, which was then eventually acquired by Red Hat and is now sort of through many iterations, just like Cloud Foundry's gone through many iterations now. So we've been watching this discussion for the past 7 years. But coming back full circle to the point here I'm making about platform as a service software is that if you look at the PC era where we first start off with this very rudimentary PC, Apple II and DOS, and then once the market started improving itself, they leveled up and created a much more usable and both customer-friendly and developer-friendly platform. I think we're seeing the same thing in the cloud space. And the software that we see today are some of the ones we see mentioned up here. But you could say, just using Cloud Foundry as an example, because that's one I happen to know a little bit more about, Cloud Foundry runs on top of different infrastructure as a service software. You can run it on top of Amazon EC2. You can run it on top of OpenStack. You can run it on top of VMware vCloud. So it can run on top of those other top infrastructure as a service products. Now, trick question for you. To take this analogy even further, what operating system did Windows first run on? DOS. So Windows first ran on DOS. It was a shell on top of DOS. Eventually it became so popular they decided to just completely get rid of DOS, and it became its own entire operating system. But in the beginning it wasn't really an operating system, it was more of a shell. And you could think about that with the platform as a service products out there today. They're just a shell on top of infrastructure and service. But someday, if one of them becomes incredibly popular, I think it'll stop running on top and actually become the entire stack. So anyway, I'm just sharing this with you because this model seems to be evolving. It's not going in a completely predictable path, but it does seem to be moving forward. So I thought this would be an interesting opportunity to talk about the different stacks that are out there. I mentioned some of them, but also we've now seen Kubernetes and Mesos also are important technologies that are having an impact on this evolution. And then of course Docker, which is I would say more of a building block, but it certainly is also impacting this overall evolution. Yes, Ed?
A quick question for you. So you mentioned that Cloud Foundry is supporting right now, supporting multi-cloud, right? That'd be cool. But the problem is, I'm not sure OpenShift also doing that or not. But the problem is, if we do everything using Cloud Foundry, we're gonna be locked. It's a locked in with Cloud Foundry.
Sure. So I mean,
that's a problem.
you can as you go up the stack, you are becoming more and more dependent on that stack. That's
Yeah,
absolutely true. But at some point, doing everything by hand gets tiresome.
Oh, yeah.
Okay. So as they evolve and mature, you start picking stacks, right? We're not writing all of our applications in C programming or assembly anymore.
We
right?
want like a Java, like a pass form as Java, so that you write once, you run everywhere. Right?
Well, I don't want to get into like the sort of nitty gritty of the specifics of a language and a stack. I don't think that's possible to determine. I'm just saying that there's this group of functionality that we can call platform as a service, and they're becoming more and more valuable. So anyway, that's sort of a little background. I don't predict this is going to be the future. It's just something that I've noticed, and I think it's useful to understand that platform as a service is slowly becoming something that we are witnessing evolve. Who knows? Maybe and of course, there's always wild cards. You know, the mobile space is a wild card. Mobile is very, very popular. We have yet to see a popular backend as a service that could become platform as a service. I don't think we've seen anything, you know, capture, like try to make that leap. But just so you know, backend as a service is essentially platform as a service for mobile apps. Okay, because the mobile app runs on the hardware, right? It runs on the phone mostly, but it still needs to talk to something in the back end to save data and you know, use additional services. So a back end as a service vendor could come out of nowhere and somehow, you know, take a strong lead in this space. You know, again, there's lots of them out there. I haven't seen any of them really capture our imagination yet, but that could happen. So there's some wild cards out there. So Google App Engine is primarily running on only Google, and Amazon has their own stack. You know, Elastic Beanstalk. Thank you very much. So and you know, and then again, there's Heroku. I mean, there are some popular platform as a service stacks that only run on one cloud that could, you know, someday they could open source that. I know that somebody had made an attempt to create a open source version of Google App Engine. I think, I forget what it's called. Anybody remember what that's called? They're still out there. I don't want to say they're done, but I don't hear about them that much. I forget what they're called. That's Santa Barbara.
And one more issue is, suppose we go Cloud Foundry because it supports multi-cloud, which exactly what we want. But the problem is, for existing workloads, suppose like enterprise application running on AWS, how do we do migrate?
No, you're absolutely right. I'm not claiming that this is going to wipe everything else out. In fact, the pattern I keep seeing over and over again with cloud is once something starts running on somewhere, you just leave it there. Because you rarely ever see like a big application migrating from stack to stack to stack. It's a lot of work for not a lot of gain. So you don't see that happening all that often. Anyway, okay, so I want to give time for folks to show up. We're at the thing. I want to give you a little bit of background here, just to kind of set the stage. And now what I'd like to do is invite some of the speakers to come up one at a time. Again, I don't know if Saeed was able to make it here. Is Saeed here? Not yet. Saeed, okay. So why don't you get ready? You can come up next. Okay. Do you have anything that you want to? Any slides or anything you want to present? You just want to come up?
I really don't have anything on the Cloud Foundry update, but.
Oh, it's okay. Come on up. I just put your name there. You can talk about IBM.
Bluemix.
Bluemix is all I can talk about.
Bluemix guy.
I'll ask you a couple questions to get started. And you've been running some of the. Well, tomorrow will you be running the track or?
I will be doing one tomorrow
One tomorrow.
on Bluemix and IoT. So it's a pretty fortunate.
Okay. Well, thank you for coming. And Rags is also a IBM.
I had a sign out on the.
Okay, perfect. Yeah, so since you don't have slides, and this is again fairly last minute grabbing folks who were here at the event, I just want to ask you some questions, and if you want to then take it from there or whatever you want, go ahead. But just by setting the stage here, IBM is a sponsor of the Cloud Foundry project and the foundation. But Bluemix is not just Cloud Foundry, right? So how would you describe Bluemix?
Okay, so I think initially it started off as mainly Cloud Foundry, so platform as a service. But you know, the recognition is that you know, it's not again one size fits all. So the idea is that you may want to provision virtual machines, you may want to provision containers and all that, and all of that. Think of IBM Bluemix as a single pane of glass for all of that, right? So whether you're doing virtual machines with OpenStack, whether you're doing containers with Docker, or whether you're doing Cloud Foundry applications. So Cloud Foundry applications, what I mean by that is, you know, we have over, you know, more than 100 services that you can plug into. You know, one of the most popular services that most people have seen, you know, because of Jeopardy, is the Watson services. You know, which really has a, you know, if you just do a Google search for Watson developer, you know, you'll see a number of, you know, examples of that. And those are all plug and play with with, you know, the Cloud Foundry apps, with the containers, kind of the same model with everything, the same concept is, you know, you're able to push an application, you're able to bind a service, and you're able to scale. You know, it's insane.
And the other part that IBM has announced is rich portfolio of middleware that IBM has for the enterprise. All of that will become a service, not one service, but a lot of services for those on Linux. So all this big enterprise software that's sitting there will be available as a service on Linux. So we'll be adding those services.
So let me ask you something. So you add these services in, but let's get back to those, for those folks who are still learning about either platform as a service or at least learning about Cloud Foundry. What is Cloud Foundry? Why is Cloud Foundry something that is valuable for IBM to include into Linux? Like, what does it do that is valuable?
Yeah, I think we had a discussion today, you know, I think IBM recognizes that, you know, innovation does not happen just within IBM, right? So IBM has been a strong believer of, you know, way back from the days of Java, right? You know, they were a supporter of Java, even though Sun was responsible for the invention of that. They are a big supporter of Cloud Foundry Foundation because they believe that, you know, it's vendor neutral, it has its advantages, we can differentiate with the services that we offer. Support of OpenStack, support of Docker, support of Node.js, you know, so you know, the list goes on. So I think it's a recognition of the fact that, you know, innovation happens elsewhere, as, you know, Bill Joy from Sun, you know, mentioned that, right? So innovation does happen outside, and you cannot always say that, you know, we're going to base it only on on what is invented within our company and kind of build on top of that, because that's not the way how communities are working.
Okay, so then, but getting back to that question, you know, what does Cloud Foundry do if I'm a developer and I want to start using, you know, Bluemix, which has Cloud Foundry in it, and Cloud Foundry is, like, what is it doing that I get a value out of?
Bluemix is Cloud Foundry. Cloud Foundry is the base. It's just
Okay, so
extending
base.
the services. So what you use CF push. I mean, you use CF command.
So tell folks what CF push is.
Yes. So Cloud Foundry command line, when you do the commands, you use Cloud Foundry commands to get your application into Bluemix. Bluemix is a Cloud Foundry running on IBM software. So it is one region that's running here that you push your application in. But it's a platform. Now, extending that platform with all these services is where you get the value in it. That's what IBM is bringing. IBM focused on the enterprise, bringing that down to the startups, to the entrepreneurs, to the developers. That's what Bluemix is. Bluemix introduces you to that part of the, like you mentioned, Watson. Watson services are being used by financials, by hospitals. They're spending millions of dollars to install it. They have petabytes of data as the data sets or purposes. What IBM does is provides those services on Bluemix for you to play with. You will have a very different idea of how to use that speech to text or language translation or whatever, personality insight. That service that you will come up with an idea of using it. The data set that you will have will be smaller, might be just one industrial, one sector, like it's healthcare and one other energy and something. So the question and answers that you will ask the question and answer service will be more targeted to that. But now you get a feel that I can have my application ask a question and get an answer. It's not a search engine. It is a cognitive engine.
Okay, so that would be an example of one service that you can access if you built your application and deployed it on Cloud Foundry.
Just an example.
Okay.
Yeah.
Okay. All right. So since we're not going to spend a ton of time with each speaker,
Exactly.
I wanted to get a little bit of a sort of a flavor, so to speak, as to what you might get if you're using Cloud Foundry in Bluemix. And just to be fair, you know, there are other companies out there who are offering Cloud Foundry as a
There's
service.
no lock-in. So
Right.
you are not being locked into this one company. It's not proprietary. You can pick up that application and take that application in another Cloud Foundry setup in that same application.
And just to give a practical example, you know, I'm not going to take more than 30 seconds. So last week I was in Java 1, and I've been doing a session for about 10 to 12 years now. And essentially it's like what I call it as a script ball. There are a number of scripting languages compete, and the audience picks the winner, right? So basically what the audience do is they text, you know, 1, 2, 3, 4, 5, who is the winner, right? to a particular message. So, I mean, to a particular number, right? So they text that. So I used to do this with an elaborate set of modems, SMS cards and all that earlier. And then I gave up, it was just too much work for me, right? So this year, actually, I used Bluemix. And all that I did was use a Twilio service, right? So Twilio does wonderful messages and all that, right? So all that I had to do was use the same Cloud Foundry model, right? Connect to the Twilio service, and essentially Twilio would have, would handle all the messages, and I would store it in a cloud database and do whatever I want to do, right? So it's the same Cloud Foundry push, bind to a service, and scale your application.
So to just kind of summarize and then also set the stage for the next folks coming up, Cloud Foundry as a platform as a service is a place where you can deploy your code, and then it can leverage services provided by third parties like Twilio, etc. Red Labs, company I work for. But it also can consume services that IBM brings into the mix as well. Okay. All right. So you get the idea, right? So you have platform as a service. You deploy your code on top of this platform as a service. In this case, we're talking about Cloud Foundry is a platform as a service. And then there's third-party services out there that you can leverage. And then, of course, IBM will bring in their own services. And I'm sharing this with you because I'm setting the stage for my own prediction at the end. So at the end, you get to hear another prediction from Dave, which is whatever, it doesn't really matter, but it's fun for me. All right, so thank you very much, you guys. We'll go ahead and go to our next.
So we're going to be around, but I will not be here. I'm head out because
Yeah, family calls, I understand, that's cool.
But I'll be around.
And then you guys have some sort of track or something tomorrow, isn't there? Or is it today?
Tomorrow.
Tomorrow, okay. So you can go learn more from that. All right, so thank you
Thank
to
you.
IBM folks, Rags and Satan. All right, so next up, we're going to go ahead and go with Jason Hansen. Right back there. He's going to bring up his laptop, so we'll switch him over in a second here. Still not working, so let's project. Okay, that's fine. And then, go ahead. For those of you who stick around, I got some res. So, you guys stick around to the end here. Some of you do. I don't know. All right, and I don't really have much of an introduction, Jason, other than you're chief architect.
Yeah,
And at engineer, did you come from engineering?
I did come from engineering. I've been there about 5 years now. And engineer just recently joined forces about 6-7 months ago with a small company out of Boulder named CloudCamp. They created DAS, open source platform as a service.
Okay, cool. So I will let you, you kind of heard my Q&A there.
Yeah.
So you can do your thing and 5 or 10 minutes or whatever you want to do.
All right.
Did that work?
Yeah, it did. I just have flux, so it makes everything orange because the sun is coming out. So DAS, my name is Jason Hansen. It's my email address if you want to shoot me a question. You can follow me on Twitter. I am at @SlackX. I usually tweet about dogs and what I'm eating. Not a lot of cloud stuff, but I'm nice on this slide actually would have worked really well in the previous conversations. This was created by the CTO at Engineer, Gabriel Monroy. He calls it the strata of the container ecosystem. And as with the OSI model, he divides things up into 7 layers. And we can argue about everything on the right-hand side because all of these projects are moving all the time, forever and for always. They're either expanding or contracting or moving around, but this is useful to ground some of the conversations that we have around what the hell is this thing that we're actually doing. At the very top, we've got a workflow layer, and the workflow layer is kind of analogous to platform as a service. So just kind of, whenever I say workflow, think PaaS. Orchestration and scheduling are 2 concerns underneath that. With orchestration, we've got Kubernetes and Marathon responsible for placing containers around a particular cluster. And we'll also talk about a little bit later, Kubernetes takes issue with calling Kubernetes an orchestration system. Below that, we've got scheduling. So this is Mesos, and if you want to take the Omega paper, which informed the design of Kubernetes, that's a scheduling system. Swarm is also there. We can talk about that. The container engine itself, Docker, Rocket, OSV, Intel Clear Containers. There's a bunch of different options for packaging up a process, either using things like LXC or by wrapping it up in an entire VM and including that. And then everything below that is kind of uninteresting. We've got an operating system. It's getting commodified. We could say Red Hat. We could say it's Project Atomic. We could say it's CoreOS. We could say RHEL, whatever. Virtual infrastructure may exist or may not. You might actually be running on bare metal, or you might be doing bare metal with vSphere. You might be on EC2. You might be on GCE, Azure. And then somewhere down at the very bottom of this, there's a physical server somewhere. We just don't get to touch it anymore. And I really miss that bit. It's actually fun walking through the expo hall. It's like, oh my God, computers. I remember when I used to see them. Been in the cloud for way too long. So what is Deus? Deus, go all the way back up to the top, is a platform as a service. It's a workflow. Deus is an open source platform, so you can download it. It's distributed as a set of Docker containers, github.com/Deus. Deus runs wherever you run, or wherever you can get CoreOS to run. So if you can launch a CoreOS instance, we can run on top of it. So that's AWS, GCE, Azure, with some caveats, Rackspace, Softlayer, bare metal, doesn't matter. The other thing that we focus on with Deus is that it's small, lightweight, and easy to customize. So if you have needs for, say, specification for routing requirements or whatever, it's very easy to swap out the piece parts of the platform with your own custom Docker. At a high level, this is the system diagram for Deus. We've got the three kind of personas on the left-hand side. We've got customers, who would be the customers of your application. We've got your developers and the operator. And all three interact with this platform in their own various unique ways. At the very top, it's customers, and it's going to be HTTP into the edge routing mesh down to your application. For developers, it's going to be developers using the Deus CLI to talk to the control plane, and that's like creating releases and setting configuration. And then the operators of the cluster are using, they're below that, they use a tool called Deus CTL. That's to interact with Fleet, which is the current scheduler and orchestration system. And I'll talk about how we chose to get to Kubernetes. But again, at a high level, when we're talking about a workflow, how are people interacting with the platform? What APIs and interfaces are we exposing to developers? Deus is inspired heavily by Heroku, so git push Deus master from my laptop pushes code into the platform, and then the platform is responsible for taking that code push, turning it into an image, and then deploying that across the fleet of machines at a very high level. Deus PS, for example, allows you to, from your laptop, to check how many processes are running in my particular application. Deus scale web equals 5, for example, allows you to change the number of application processes that are deployed on top of into the cluster. And then something like Deus config set key thing equals foo allows you to change the configuration of your application on the fly. And this is not unique to Deus. I mean, Cloud Foundry has it, OpenShift has it. This is kind of concepts that you'll see pretty much across the board. But one thing that you won't see here, and when we talk about PaaS, the PaaS conversation, nowhere am I talking about replication controller configurations. Nowhere am I talking about actual Docker images, at least at this level. Nowhere am I talking about like number of machines and where they're running. That just doesn't exist, right? We've abstracted away all of the implementation for actually running this stuff in production through the platform or the workflow layer. So there's a scheduling conversation here, there's an orchestration conversation here, there's VMs, there's all this kind of garbage underneath being taken care of with the platform. So additional services that come along with Deus, we've got log aggregation, we have release and rollback, we have source to image via the builder component, and we have edge routing. The one interesting piece, I actually left the slide out, but is the source to image. So a lot of the open, like Kubernetes, for example, doesn't take a position on how you take a code repo and turn it into a running process. They say source to image is no problem, just plug in Docker images or Rocket ACIs, and we'll run them. Deus provides a builder component which supports 3 workflows. The first one is a build pack, so if you've used Cloud Foundry or Heroku, you'll be familiar with that. You push your code in, the builder component takes your code, looks at it, wraps it with the build pack, pulls down all of the dependencies, turns it into a tarball, and then throws it over the fence. second one is a Docker file-based approach. So if you want more control, and there's a Docker file in the root of your source repo, we will then read that Docker file, create an image, and then deploy it across the fleet of machines. And then the last one is Docker image-based deploy. So if you've got a CI/CD pipeline and the end result is a Docker image that gets thrown up to a registry, you can point the Deis platform at that Docker image, and instead of a code push, you just say, hey, there's a new image, we'll pull down the image and then deploy it across the fleet of machines. And if anyone has any questions, feel free to ask at any time. So those are the bits and the pieces of the platform side. So open source project, we throw it out to the world, people start using it, and then it starts breaking. And one of those reasons that it started breaking was that we had chosen a scheduling and orchestration system that was new, but had some problems with it, and that was Fleet. I still like Fleet, but it's got some problems. The first one being that it's not resource aware. So when Fleet looks at a pool of resources, and it looks at some task that it wants to schedule onto those resources, it doesn't know how much CPU, RAM, and disk is available across the cluster. So it's like, holy shit, I don't know, I'll just put it somewhere. Which works when you're in a steady state. But when things start falling apart, Fleet makes some really terrible decisions about where to put things. So if you have a new node come into the cluster, for example, Fleet says, well, I've got 5 things here, 6 things here, 10 things here, 0 things here, and the next 5 things in will be all on the new box, and then it'll start round robin again. And in failure conditions, that's not awesome, because you'll end up putting all of your stuff on one box, and then when that fails, you're in the world of hurt. So we started looking at what options do we have out there. We evaluated Kubernetes, Mesos, and Swarm as different scheduling and orchestration systems to re-platform on top of them. And the fun thing was that we did this with the Deis community as well. We released 3 tech previews where the Deis platform talked to 3 different scheduler implementations and orchestration implementations. One with Kubernetes, one with Mesos, via Marathon, and then one with Swarm. We released all of them, and unanimously, well, not unanimously, mostly unanimously, enough to give us confidence in choosing Kubernetes as the orchestration and scheduling implementation. That one won out. There's a big chart. We've got a bunch of different things on it. We'll talk about the things that we liked about Kubernetes. Was 1, it was resource aware. 2, it was mature in that it had been informed by the things that people learned via the Omega paper at scale. Talking about scale, the 1.0 release was 100 nodes and 3 pods per node, and they're quickly working up the scale, up in scale, as Kubernetes starts to mature. The resource requirements as well for Kubernetes are small to medium, much smaller than Mesos, for example. You don't need to run Zookeeper cluster. You don't need to have a job runtime. It's Go binaries. It's small. It's easier to deploy. And the community with Kubernetes is large and growing very rapidly. The velocity inside that community is quite nice. One knock against Kubernetes is that the internal complexity for Kubernetes is a little bit higher because you need to have things like overlay networks. So getting a Kubernetes working can be a little bit weird sometimes. But from an implementer standpoint, a platform sitting on top of Kubernetes, the complexity is actually much, much lower. So with Mesos, for example, Mesos out of the box doesn't give you anything. It's just like a command execution framework. You need to run a framework on top of Mesos to get it done. There are a couple. Aurora was created by Twitter. There's an application deploy framework on top of Mesos, and then Marathon is another. As a system implementer in Deis, we were looking at it like, okay, well, Marathon doesn't actually do the things that we needed to do. We need to have interactive command execution. We need to do a bunch of different things that Marathon can't do. So we're kind of stuck. So do we do half the stuff in Marathon? Then do we write our custom framework inside of it, or do we totally do a custom framework? It just ended up feeling a huge impedance mismatch.
So are you using Kubernetes along with Mesos?
We can, and if anyone
Because
here
if
is
you
using
use
Mesos,
Kubernetes, as far as I know, Kubernetes does not support multi-tenancy.
Kubernetes does not support strong. Well, we we need to talk about what you mean by multi-tenancy. Strong isolation, no, I don't think anyone would make
Mesos
that claim.
support multi-tenancy. It's not a different user. It's like a different kind of application. Like I have a Spark cluster as well as I have a Kafka cluster. And there's the application.
Yes.
They're running on.
That is, yeah,
Yeah,
that's
same-
completely
same
true.
cluster.
Yeah, Mesos is a two-level scheduler,
Yeah,
so
yeah.
you can actually have multiple frameworks running in a Mesos environment.
Yeah, sure.
And Mesos will handle resource grants to multiple frameworks, and Kubernetes doesn't do that.
Yeah.
For our purposes, that wasn't an interesting aspect, but it also allows folks to run Kubernetes in the context of Mesos. And if anyone here is doing that, I would love to talk to you about why you want to do that, because I think it feels a little bit weird. But yeah, so Kubernetes was nice. It's a lightweight, there's this concrete set of APIs. I mean, OpenShift folks who figured this out a while ago. So onward and upward. So DSV2 is